Okay, this is a video on proper scientific notation, what I call scientific notation, engineering notation, how things get entered into Scilab or MATLAB, and what LT Spice recognizes. So if I start with a number, any number, 1500, and I put it down here, 1500 can be represented as 1500 times 10 to the 0. And to make something into a scientific notation or put it in that form, you can always take the number you're given and multiply it times 10 to the 0, because 10 to the 0 is equal to 1. And if I get my superscript right, it'll show it. And then I bold that, because that's what you need to do, and you need to say it till you remember it. 10 to the 0 is 1. So 1500 is equal to 1500 times 1. I'm sure you'll agree with me on that. And now my decimal place on 1500 is over here to the far right end of the last 0. That's the convention we all are used to. And if I move that decimal 3 places to make it 1.5, this number got smaller by 3 decimal place movements, which is exactly equal to what the tens power has to increase from 10 to the 0 to 10 to the 3. So this number is equal to this number, which is equal to this number. Now, when we go into tens powers, I have certain tens powers that correspond to engineering prefixes, and sometimes they're called metric prefixes. And basically it's powers of 3. If I'm 10 to the 0, I don't have a prefix. It's my base unit, if you will. 10 to the 3 is kilo. 10 to the 6 is mega. Minus 3, milli. Minus 6, micro. Minus 9, nano. So if I'm dealing with meters, for instance, and I see a 10 to the 0, I've got meters. But if I have 10 to the 3 meters, I really have kilometers, or megameters, or millimeters, or micrometers, or micrometers, or nanometers. So I can put them into different forms. So I'm taking this 10 to the 3 and I'm replacing it with a K. Since it's multiplied together, that's usually the shorthand you see it. 1.5K. If I want to enter it into Scilab, mathematical software recognizes the lowercase e as being saying I've got an exponent. It's an exponent, and it assumes it's a power of 10, and all you have to do is type the power. So 1.5 e to the 3 Scilab would recognize as 1500. And if I'm putting it in LT Spice and I want to put in a value, say, of a resistor, 1500 resistor, I could type it in as 1.5K. And Spice would recognize the K as a power of 10. A lot of the softwares will do it. One thing Spice won't do is it won't recognize this uppercase M as mega. It recognizes it as milli, because I've tried it and I've seen that. So that's a pretty normal number, 1500. You can put that in on your calculator. And then I did one that's actually not below 0, but less than 1, really close to 0, really small. So I've got this number, I just multiplied it by 10 to the 0, which is exactly what I did in the line above. I counted over how many times I had to move my decimal place. This time I'm going to the right 4 places. So if I go to the left, I go positive. If I go to the right, I go negative. So I went from 0 to minus 4. And the way to remember it is this number here is bigger, 6.78 is bigger than 0.000678. So if your number gets bigger, your exponent has to get smaller. And sometimes smaller means going into the negative range. So that's an easy way to remember it. And 678 times 10 to the minus 4th is not in my table over here. So I went ahead and moved it 2 more places, 10 to the minus 6. These again are equal. 678 is bigger, so it had to get smaller by 2 more, so -4 to -6. And I could have gone to milli. I could have made it 0.678 milli. Just move my decimal the other way to get to the table. Ordinarily, though, you're looking for something with a number, not just starting with a decimal. Most instructors do that. Hopefully, they'll start out, get your answers right, and then worry about form at the end. So then I can go into micro and get rid of that 10 to the -6 and put the U by it, and then I've got it. When I go to enter it in Scilab, I'm going to do it just like I did up here. 6.78 e to the -4. I went back to scientific notation. I could have used any of these with it. I don't have to have it in proper scientific notation to enter it in the Scilab. And in LT Spice, not sure if it recognizes micro. I have to check that out, but that's how you would enter it. And these two numbers are pretty straightforward, easy to use. You could enter them in on a calculator. You don't have to do all this. But what if you have like the distance to the sun, 93 million? Proper scientific notation, an engineering notation, Scilab, LT Spice. All this gets easier if you put it into the proper forms. And if I've got something like the charge on an electron, which is this number right here, if you can imagine, I'd have to move this decimal 19 places. So I'd have a dot, 18 zeros, 1 6 if I had to type it out in this box. And this box physically wouldn't hold it. So that's proper scientific notation. And I can put it into an engineering notation. I'd have to go look up a table, see what the next entries are. But I could do it. And I could represent any number you can imagine within a scale. And the reason that scientific notation was invented or is used is to make math on very large and very small numbers possible. It actually makes it easier, and you can do it without a calculator. So, what is 10 to the 0 equal to? And proper scientific notation, 9.3 times, what do I get if I copy all that? Not what I want. 10, I'm moving my decimal place. How many? 1, 2, 3, 4, 5, 6, 7. 10 to the 7th. Make it a superscript. That's not a power of 6, so I've got to make it 93. I'm going to make this number bigger. Therefore, I can make this number smaller. Now I can turn it into an engineering notation. 93 capital M. Scientific notation or Scilab, I would type that in as 9.3 e to the 7. LT Spice, I'm going to have to go back to the K, which means I need 93000 K is the best I can do in LT Spice. If I have a 9.3 meg resistor or 93 meg resistor, that's how I'd have to enter it. So you can see that the process is the same. Once you learn it, once you practice it, you got it. Thanks for watching.